Hey, I think we're live. Good morning, good afternoon. This is Benjamin. I'm with Ian. We're back from EclipseCon Europe, which was last week in Europe, in Germany. We had lots of great IoT content, and actually we met Gordon Williams from the Espruino project, and we thought it would be a good idea to have Gordon on the show today to talk about what is Espruino. So I kind of know a bit about it. I saw your session. It was actually pretty good. Ian, I think you wanted to use the opportunity of this session to learn about Espruino, right?
Yeah, I missed the session, but I heard all sorts of really cool things about it. Kind of using audio output to control, was it coffee makers or something like that? But why don't we just kind of start with, okay, what is Espruino, and then kind of we can go from there. So Gordon, can you kind of lead us, kind of give us the high level of what Espruino is? What are you trying to accomplish?
Okay, so it's basically a JavaScript interpreter that runs on really low power microcontrollers. So we're talking about the kind of things that have less than 100 kilobytes of RAM. So that means it's not really suitable for running something like V8 on or Node.js, because they're just designed for for somewhere with a lot more memory. They'll allocate big buffers at startup, and it would just be a mammoth task to try and skin them down enough to fit everything in. So that was kind of started out of wanting to make development easier on microcontrollers. I mean, stuff's got a bit better now, especially with Arduino and all the support that manufacturers are pouring into that. But it used to be that to develop for ARM, especially on Linux, was kind of quite a painful process that may even have involved trying to compile your own compiler first before you even managed to get doing anything on the microcontroller. So in a way, like a really nice way to work around that is to just put all the tools you want onto the microcontroller itself. And people were doing that with like the BBC Micro and the Commodore and the Spectrum and all those things. It's sort of 20, 30 years ago. And they were actually very similar spec. In fact, a much lower spec than the kind of microcontrollers you get today for a few pounds. So it's kind of basically taking a modern high-level language and squeezing it into the same footprint that you would have run BASIC on 30 years ago.
Yeah. So have you put a JavaScript VM on kind of a microcontroller? Is that essentially what it is?
Yeah. So
have you ported V8? Like, did you port V8, or have you written your own?
No, it's actually my own. I had like almost a single file JavaScript interpreter that was very, very noddy, that I'd done just as a way to kind of automate some tools I've made for myself. And I realized that would fit on, and then over time I've kind of built that up to the point where it's actually a much more complete JavaScript implementation with quite a lot of ES5 in it as well.
Wow, cool. So what are some of the types of kind of applications people are building with it right now?
Okay, so at the moment there's still quite a lot of homebrew stuff going on with it. So I've got people doing lights. There's kind of sensing and stuff like that is quite useful, and attaching it to low power radio. There are a few people experimenting around with that. Trying to think for some other examples now as well. Someone's doing a GPS system for his boat. So he's got the GPS. He wants to be able to choose exactly what is put where. The speed, the coordinates in the format he wants, and it just gives him that flexibility. And while you could do that on a Raspberry Pi, it would take a little bit of time to boot up, and there's quite a lot of messing around to actually get a standard Pi with an SD card with Linux on it, booting up, running your code and everything else.
The Raspberry Pi is not really low power, right?
No, exactly.
I think you guys you can run on the battery for like 2 years, right?
Yeah, so this is one of the nice things about the running it on a microcontroller, where everything's in one chip. And one of the things about JavaScript is that you've got it encourages you to write things in an event-based way. So you say, when the button is pressed, do this. 10 seconds later, do that. And the interpreter then knows exactly what it's waiting for before it has to wake up, whether that's a time period or an input changing state or both or something else. And it can put itself into sleep. And these microcontrollers go to sleep and draw very little power at all. We're talking about, is it about 40 microamps for the microcontroller? And then some of the stuff on the board takes a little bit more. But the end result is that you can write very simple code and have it run for years on a battery, as long as you're sensible about how often it's going to wake up.
That's amazing. So basically, you've simplified the whole technology stack.
I suppose, in a way, it's going back a bit, because you would have had in one of these older computers, you wouldn't have expected to have like really a whole operating system sitting underneath the basic interpreter. And in fact, there are basic interpreters out there at the moment that do a similar thing, and there's eLua, for instance, which doesn't have much underneath it as well. So in a way, it's kind of building up rather than trying to tunnel down from Linux. So you end up in kind of two different states. You can have a really stripped down Linux like OpenWRT, which will run in 32 meg of RAM, and it will be very useful for a lot of stuff. Or you can build up and just add a little bit more usability to a low power microcontroller.
So
Very cool.
yeah, you're talking about Predator, but then maybe we will see some code in a few minutes. But what are the kind of modules and libraries that people can use? I know that, for example, you're starting to work on supporting sockets, and what are the kind of other libraries that people could be used and require in their code?
Yeah, so there's quite a good variety at the moment. I forget exactly how many we have. I think it's probably around 40 or 50 modules especially written for it at the moment. And they handle things like we've got 10 different types of LCD display you can use, a few different kinds of radio, GPS, lots of stuff like that. But actually built into it, there's also support for the CC3000 Wi-Fi. And if you get another build, there's support for the WIZnet Wired Ethernet. And when you get them, then you get an HTTP server and client built in. And it's just something that, it saves you from pulling in loads of JavaScript just to have it. It can be done much more efficiently internally when it's written in native C code. So those are nice things that are part of it. And you've got a lot of standard JavaScript stuff built in as well. You've got all the maths libraries, all the stuff for strings, and all everything you'd expect with JavaScript, where you've got the arrays and objects, and a lot of work's done for you compared to C, where adding a bunch of strings and numbers together actually could be quite painful because you've got to start thinking about buffer sizes and all the rest of it.
All right. So should we look at some code? Should we? Can you show us some code?
Yeah, sure. Right. Well, let's. So yeah, I'll just go on and show you the web IDE. So first off, this is one of the standard Espruino boards that's kind of available now. And then there's like.
So where do people get these boards?
Okay. So these are available. Trying to think, there's Digital Means in the UK, there's Adafruit in the US, which is a big one. But basically, go to the Espruino site and there's a list of distributors because we've got quite a lot at the moment.
Okay.
And there is a Kickstarter on for a really tiny board.
Oh wow!
So that's kind of going at the moment. It's sort of halfway through. So if I
the first Espruino was also a Kickstarter, right?
Sorry.
The
first board was also funded by Kickstarter, right?
Yes, yeah. So sorry, it's a bit of a going off topic a bit, but yeah, it was the software was originally started to try and make it easier to develop for our microcontrollers. So it worked for a load of ST discovery boards, and it wasn't. Like a lot of people who wanted to use JavaScript on a microcontroller were put off by the fact that in order to use it, you had to learn enough to flash it onto the microcontroller first, which isn't a very easy task. So the Kickstarter actually was for a board that had everything pre-installed and it just plugged in and worked, and you didn't have to have any tools. So yeah, if I go over to a screen capture and I'll show you what it's like. one.
So maybe while you set up, we actually have a question. Speaking of libraries that people could eventually use, do you think that would be possible to have support for libraries like underscore.js to do like functional programming kind of stuff, map, collect, etc.? Is that something that would fit into the board?
I think I don't know enough about underscore. I think just it may struggle initially. So you could do two things. You could either you can run it through a like the closure compiler, which will actually minify the JavaScript code and will pull out all the code that you're not using. And then just the act of pulling out the code that you're not using would probably be enough to fit everything in. So yeah, I mean, bigger libraries like that, you kind of could conceivably get it in, but you're stuck with this problem that you've got a microcontroller with, in this case, sort of 48K of RAM or something, and that is 48,000 characters. You're going to struggle to get bigger library in. I mean, jQuery is like 80,000 characters or something. So when people ask about getting that in, it's not possible unless you have a very skinned down version of it.
Yeah, makes sense.
Okay, so shall I swap over and
Yep.
do okay?
Yeah, that'd be great.
Okay.
So this is
code.
So you said it's Web IDE. It's something that you run from the browser. Is it like running in the cloud, or it's a Chrome plugin or something?
Yeah, so it's a plugin for the Chrome web browser. It's a Chrome web app, and the only reason it really has to be a web app is that Chrome is the only browser that lets web apps access the serial port. So you're kind of a bit stuck that trying to talk out from a website to the real world is quite difficult. But this was we can cover that later. That was one of the things that I covered on my Eclipse talk. So this is the web ID. If everyone can see that, can they?
Mm-hmm. Yep.
Okay. So if I go and connect to the board now, I'll just move the camera around so hopefully we can be able to see it a bit better. See if this works. Okay, so you've got on the left-hand side, you've got a terminal, which is, it's just a standard terminal, not doing anything very intelligent. So it could be like Minicom on Linux, or Putty on Windows, or even Screen on Mac, which is pre-installed. So if I type things here, every character I type is actually sent over to the board, and the characters come back as a reply, and it's displayed. So if I do this now, it's actually executed that on the board itself. And you can write Arduino-style commands. If I light the LED up, it'll happen like that. And because these characters are just sent over, you can actually not have the web IDE, but you can echo them over the serial port. So on pretty much any operating system, without any software at all, you can still get it to do stuff in the real world.
Right.
So I mean, you can do things here, and you can actually you can define functions, and this sort of multi-line editing is all happening in the chip itself, as well as the command history. So I don't know if
That's cool.
yeah, actually let's do that. And if I do set, then hopefully we'll see it flashing. And you can just say something like set interval, which will hopefully keep it flashing.
Which is exactly when. Yeah, go ahead.
Yep. So 10 times a second. So this is happening, but you can still do things in the background. So for instance, I can, because it's JavaScript, I don't have to put in a single pin because it's not typed. So I can put in an array here, and then I don't know. That'll probably still only set the first one. So I could actually just add 1 to L all the time, and now it's it's counting up in binary on the 3 LEDs. But you've been able to change that function effectively while everything was still running. So that's the terminal side of things. on the editor, you've got a syntax highlighted editor. So if I just pull in a little bit of code, I'll just grab something off the website.
And right now, what will happen if I reboot the board? The program is just running in RAM right now, right?
Okay, yeah. So if I rebooted the board, then it would completely stop. But you can just type save, and it actually saves almost like the image of RAM into flash memory, which is flash memory in the chip as well. So if I just hit reset on the board now, and then let go, it'll boot up and it'll carry on exactly where it left off, and then reconnect to it again. So yeah, you've got this side of things. You've also got this syntax highlighted editor, which is, it knows a little bit about what you're writing. So if I typed in A2, which is a pin, and then control space, it kind of tells me the things I can do on that pin, and obviously you've got a bit of documentation as well.
So the editor is actually very specific to the board. Basically, it's kind of context sensitive to your board.
Yeah. So when you connect to the board, the Web IDE, it just queries it a little bit to find out something about it.
Right, yeah.
And then it can look up on the internet and find out what the pins are, which pins are connected to the LEDs, and all the rest of it. So that's all quite handy. And it just helps you out. It'll save you looking at the manual quite a lot. If you type in DI and there's something called digital write, you can get the idea of what you need to do.
So one of the things I was wondering is, could someone take the software environment and port it to a different board themselves?
Yeah, absolutely. So
and do you want that? Is that kind of part of the strategy here, or?
It's difficult. I don't particularly mind about it, and in a way it's quite good from the point of view of debugging. And the more boards you port it to, the more architectures, and the more likely bugs are likely to show themselves up. Right. So the only issue right now is support, because effectively I'm trying to do this full time, and the only way I can really fund it at the moment is either by sales of the Espruino board, or if someone chooses to give some proportion of the Espruino board that they sell to help support it, and right. No one has to do that. Yeah. So again, I'm kind of a bit. It's a difficult situation, but it's working out really well at the moment, actually. So yeah, this is what it looks like. If you say require, it will. It'll go on the internet and it'll look and try and pull in a module of that name, and it'll load it into the board so that you can write quite simple code, and this will be pulling in a library which will communicate with that particular type of display, and then there's a little built-in graphics library which will display hello.
Very cool.
So yeah, shall I swap back to me? I think.
Should we talk briefly about kind of what the demo you did at EclipseCon Europe? I don't think you're set up to give it, but kind of what did you show off at EclipseCon Europe?
Okay. Yeah. So I kind of hinted at before. The problem you've got is talking out from the internet to a board like this one. I mean, it enumerates itself as a USB serial port. So you plug it in, and then all you need to do is access the serial port. But for very obvious reasons, web pages are not allowed to access the serial port on your computer. And there are actually very few things that they can access. They can access a display. If you're lucky on a phone or something, they can access an accelerometer or a magnetometer. But there's not much in the way of an I/O device. And about the only thing you can do is you can make sound and receive sound. And it turns out that with a few really simple components, it's about to actually transmit. It's just one resistor and one capacitor. You can create a sound wave of the right shape to make it look like a normal old-style communications port. So you don't actually need any software on this. You just get it out of the packet, and it thinks it's talking to a normal terminal, but it's not. It's talking to a website via your audio jack. And we've tried around and demo Gremlins during EclipseCon, but apart from that, it actually works perfectly on everything I've tried it on. Really, it's surprisingly reliable. So hopefully, given a bit more work, be able to have a cable and so the whole point of this is that with something like Eclipse Orion, you can write a really simple plugin that will take that code that you've written, will do whatever's needed to it, and will send the JavaScript code straight over what is this kind of weird audio communications port. And now you have absolutely nothing to install at all. It will work on almost any device. You could kind of see that you could develop it on your PC, and then you could go out into the field, load up Orion on your phone, tap that button to say program the board, and it would program it from your phone's headphone jack. So it's kind of...
I guess you could also do Bluetooth audio, right? You could do wireless.
Yes, yeah. Yeah, so there are a huge amount of things you can do with it, and it's a little bit of a hack, but it does work pretty reliably. So but why not?
Yeah, for sure. Very cool.
Maybe back to the Pico and the current version of the Espruino. What do you have in mind to maybe make, or maybe that's not part of your goal, but make it easier to get internet connectivity? I'm thinking maybe like making the Espruino board compatible with the Arduino Shield mechanism, or the embed. Embed as some sort of motherboard that maybe could be used for simplifying integration of the very small JavaScript microcontroller in bigger, larger designs.
Yeah, so I'm definitely I'm really interested in, especially with the Espruino Pico, making an Arduino Shield that holds it. And I think, like existing Arduino prototype boards, you could just put it on, you could wire it up. But it would be nice to have something pre-made. And I know someone's already contributed an Arduino Shield for this one, that you can go to OSH Park and you can just kind of order the board to be made for you, kind of on demand. So that would work really nicely. And as I said, they've already support for the CC3000 and WISNet's wide Ethernet module as well. But there's also there's a new chip that some people might have heard of called, I think it's the ESP8266. And that's a really, really tiny Wi-Fi module that is about the size of that bit of the chip that you could see, and it costs about, I think at the moment it's about $4.50 per board. So it's really, really cheap, really really kind of easy to use as well. It almost looks to the computer like it's a GSM modem. So
would there be room to actually run Espruino inside the Wi-Fi chip, or just as a backpipe?
I mean, that's something I'd looked at. The chip itself is it's not an ARM, but it is 32-bit, and there's about 128K of flash, and it's not quite enough, I don't think. But the flash is a separate chip, and it's possible that you could run it on there, which would, I mean, it would be absolutely amazing.
Yeah.
So it's something I'd like to have a play around with, but at the moment, you can just glue it to one of the other boards around, and it's only 4 wires, so it's not a disaster to wire up at all. And with the HTTP client and server that are in there, it's quite quick to knock up things. And as Benjamin mentioned, I'll be working on adding socket support soon, so things like MQTT should again be quite easy to implement.
So you could have MQTT messages coming from their Espruino board. You could generate them. You can have a JavaScript MQTT client on their Espruino board. Yeah,
absolutely. I mean, there are JavaScript MQTT clients around, so it should work fine.
Right.
I mean, the other interesting side of things is I've heard quite a bit about MQTT SN, which doesn't, it doesn't really require HTTP, but one of the nice things about the boards is that they are so low power, and Wi-Fi, one of the nice things about MQTT was that you could stay connected and you could get notified when things happen. But if you do that with Wi-Fi, then it's going to drain an awful lot of power very, very quickly. Right. So you probably don't want to do that. So like on an embedded side of things, MQTT SN could be really, really interesting. So that's another thing that I'm going to look into quite soon, because I think effectively having a bridge from MQTT SN to MQTT and then being able to use lower power, cheaper radios could be really, really exciting for especially home automation and stuff like that.
Absolutely, yeah. Cool. So I think we're coming up to the end of our session here, Benjamin. Are there other things we should cover off with Gordon, or? So actually,
no, I was wondering if maybe some people who are watching us would have any questions. So you still have a few minutes.
And so why don't we how do you developers get engaged here? Like, Adafruit and Element 14 have boards that they can buy?
I'm afraid Element 14 don't at the moment.
No, okay.
I'm hoping they will do. But,
yeah, they should.
But that all depends. So yeah, there's if you look on the Espruino website, there's a link to get them, and there are loads of distributors around that will have them.
Yeah.
In terms of getting involved, there's a GitHub repo called Espruino. That's got on it the Espruino firmware. It's got on it the Web IDE. It's got on it all the code for doing the audio to serial stuff, which should work. Not even it's not tied to Espruino. It should work on any platform. So yeah, I mean there's also the documentation is based off GitHub as well. So there's like loads of stuff that yeah, you can download it all. You can look at it. Any contributions, bug reports would be absolutely amazing.
For sure.
Yeah, just to make it clear, it's really 100% open source and open hardware, right? I checked out the source code actually a couple days ago, and you can compile your own firmware if you want to do to improve or to tweak the VM. You can do that if you want to download the files to design your own board. You can do that as well. So that's really as open as it can be.
Cool. So Gordon, what did you think about EclipseCon Europe? I think was that your first time visiting?
It was, yeah. So yeah, it was really, really good actually. There's like a really nice selection of talks, and yeah, a lot of, to be honest, is having, was it 7 or 8 tracks or something? That was the only bad bit about it. Was sometimes trying to figure out like
what to go to. Yeah.
So yeah, it's really exciting. I'd definitely be interested in coming back next year, even if it's not to talk, just to turn up and see how things are going.
Good. Well, I think what I was kind of pleasantly surprised is the number of people working on IoT. Kind of in the demo area, right, and in the sessions like that you put on, there's definitely a lot more people hacking at IoT type scenarios, like kind of the Itemist guys. Benjamin, I think you did a interview with them with their X robots, which is pretty cool, using NextX to drive some robots. And the Scout people have been doing some interesting things, connecting to kind of Scout into Raspberry Pis. So there's lots of interesting things going on this year at ECA. So it was fun.
Yeah. So the keynote actually, I'm afraid I can't remember his name, but the guy from the Isle of Wight.
Andy Stanford Clark. Yeah.
Yeah, so he made a really good point, which was that when you've got a kind of a framework in place for for automating your home, once you've got something there, it's very easy to build these little extra bits that go on, and that turns into like a fun weekend project. And I kind of hope that in a year's time there may be that thing that you can go to Maplin, you can buy one of these widgets that does provide that for you and provides the platform for you to kind of hack around and develop cool Internet of Things home devices with, because there's not really something like that at the moment, I think.
Right. Yeah. Did you did Andy see your talk? Have you talked to Andy about
I haven't. No, yeah? I don't think he did.
Okay.
So yeah, it would be worth talking to him. And
I'll try and introduce you to him.
Oh, brilliant! Thanks. Yeah.
So you guys probably live. You're in the UK, right?
Yes. Yeah, I'm in just outside Oxford.
Okay.
So
not that far.
Too bad. Nice.
That's great. Okay. It doesn't look like there's any other questions. Benjamin, do you have any other things we should cover? Or?
Nope. I think we're good.
Okay.
Well, actually, maybe a shameless plug for the virtual jack session I'm going to do in an hour and a half.
That's right.
Go to just Google virtualjack.com. I'm going to basically present the end-to-end IoT stack for Java. So take an hour or so to show lots of code and lots of samples to help people get started with MQTT, Cura, Co-op, all that kind of cool stuff that we have at Eclipse.
All right. Well, Gordon, thank you very much for joining us. This is exciting stuff. You definitely know your stuff, so it's good luck with it, and we'll certainly put some links on the recording for this, so people can easily find your GitHub repo and your website, and the Kickstarter. The Kickstarter. When's the Kickstarter timeout?
It's about 16 days from now, so it's about halfway through.
It's not about it. Exactly 16 days.
Okay.
Is it going well?
Yeah, it is. It's reached. It's twice its kind of initial funding target now. So
Great.
I've got there's a stretch goal at 50,000, and it's at just over 30 at the moment. So it would be really nice to be able to try and hit that by the end of it. I think that's promising.
Yeah, we get MQTT, right?
Yeah.
All right, we'll do our little bit of trying to help you promote that Kickstarter. So thanks a lot.
Brilliant. Thanks.
Thanks, Gordon. It was great to have you.